Hey everyone, in this video we'll be talking about limits at infinity and horizontal asymptotes. So the whole idea around this video is that what happens to the y value when x is becoming sufficiently larger and larger. So we could say in other terms, what happens to the y value when x tends to approach positive or negative infinity. So here we're given y equals to 1 over x. So when x is equal to 1, y is equal to 1. When x is equal to 10, y is equal to 0.1. When x equals to 100, y is equal to 0.01. When x equals to 10,000, y equals to 0.0001. So from this, we can see that as x tends to become bigger and bigger, right, y is becoming smaller and smaller, going towards 0. So in other terms, just using the simple concept of limits, which we've discussed so far, we could say that the limit as x approaches positive infinity, because x is becoming bigger and bigger in the positive direction. So the limit as x approaches positive infinity of 1 over x is equal to what? So as x is becoming bigger and bigger in the positive direction, y tends to approach what number? In this case, it's just approaching 0, right? So therefore we can say that this limit is equal to 0. Now a very important thing to note when talking of limits at infinity, if the limit as x approaches positive infinity of your function is equal to some number L, okay, then you can say that y equals to L is a horizontal asymptote at that positive infinity. So this is very important to remember and keep in mind. And the same thing can be said for negative infinity. So if your limit as x approaches minus infinity of the function is equal to any number L, then y equals to L is a horizontal asymptote at negative infinity, because we're approaching negative infinity in this case. So this is very important to keep in mind. So using the same idea for this example, we can say that y equals to 0 is a horizontal asymptote at positive infinity. So why do we say that? We say that because first we are finding the limit as x approaches infinity, and that limit is equal to some given number. So in this case, y equals to 0 will be a horizontal asymptote at positive infinity. The whole idea of horizontal asymptote is pretty much similar to the vertical asymptote, but just that in this case it's going to be horizontal asymptotes. So it's going to be a horizontal line. So to better understand horizontal asymptotes, let's have a quick look at the graph of this function. So this is the graph of our function 1 divided by x. So as x is becoming larger and larger in the positive direction, so as x becomes larger and larger tending towards infinity, we can see that y is becoming smaller and smaller, going closer and closer to 0, but it never touches the horizontal asymptote. In this case, it will never touch the line y equals to 0. The line y equals to 0 is this horizontal line, and that is what is the horizontal asymptote. Now let's try and solve the same example, but now using the substitution property, like plugging in the value of x. So here in this case, since the limit is as x is approaching infinity, we can plug in infinity in place of x, right? So this will give you the limit as x approaches infinity of 1 divided by infinity. So infinity, as we said, is rather like a concept, but it represents a very, very large number. So 1 divided by a super large number is just going to be 0, right? Because, for example, 1 divided by 10 is 0.1, but 1 divided by 10,000 we know is like a very, very, very small number, right? Close to 0. So that is just going to give you 0. So that's how we can do this question using the direct substitution property. Now we'll look at a few more examples just to get used to this whole new concept. So the first thing is when you have the limit as x approaches infinity of x to the power n. So this is simply infinity to the power n. So infinity itself is a very large number, and then you're multiplying it by itself. That's what the power means. You're multiplying it by itself n number of times. So that is just going to result in infinity, right? A super large number. If you have a super large number and you just keep on multiplying it with itself, you're just going to get infinity, right? Which is just a super large number. So this is just going to give you infinity. Second, when you have the limit, now in this case, when x approaches minus infinity of the same thing, x to the power n, then what would you have? So when you have minus infinity, that's when you need to be a little more careful. So in this case, the overall answer, whether the limit is positive infinity or negative infinity, really depends on n. If n is an even number, then the overall sign is going to be positive infinity, because minus infinity times minus infinity is positive infinity. That is if n is equal to 2. But if n is equal to 4, you'll again get positive infinity. So this is if n is equal to even. Now if n is an odd number, so then you will have minus infinity. Then thirdly, when you have the limit as x approaches infinity of 1 divided by x to the power n. So in this case, we know that this part over here, x to the power n, so infinity to the power of anything is just infinity. So this is just going to give you 1 divided by infinity, which is equal to 0. And finally, the limit as x approaches minus infinity now of the same thing, 1 divided by x to the power n, is going to be what? So this is just 1 divided by, now when we have minus infinity, we need to be careful of the sign. So it all depends on whether this n over here is even or odd. Okay, so if your n is even, you're going to have a positive infinity in the denominator. If it's odd, you're going to have a negative infinity in the denominator. But regardless, in this case, we have 1 divided by an infinity. So 1 divided by any large number, be it positive or negative, is just going to give you 0, and 0 has no sign, right? So it really doesn't matter what the sign of this infinity over here is. Okay, but the overall answer is just going to be 0, because 0 has no sign. So even if it was 1 divided by positive infinity, you'd have 0, or even if it was 1 divided by negative infinity, you'll still have 0. So that is how that works. Okay, so moving ahead, we'll now talk about evaluating limits at infinity for polynomials. So for example, if we are told to find the limit as x approaches infinity of 2x to the power 5 minus 3x cubed plus 2x plus 1. So in this case, how exactly do we evaluate this limit? So the trick is what's written over here. So you just consider the term that contains the highest power of x. So this term over here contains x to the power of 5. This term contains x to the power 3. This term contains x to the power 1, and this term does not contain an x. So in this case, which is the term that contains the highest power of x? Pretty obvious, right? It's this term over here. So we just need to consider this term to evaluate the limit. So then we have the limit as x approaches infinity of 2x to the power 5. So this is just 2 multiplied by infinity to the power 5. So positive infinity to any power is just infinity, and infinity times 2 is infinity itself. So this just gives you infinity. So we evaluated the limit at infinity, and we have not got a final answer which is some sort of a number, right? Our final answer is infinity. Infinity is not a number. Infinity is rather like a concept. So in this case, there is no horizontal asymptote. But on the other hand, if this answer evaluated to some number, like let's say that 0.5 or minus 1000 or 10,000 or 2 or 5 or any given number, then we would say y equals to that number was a horizontal asymptote. But since in this case the overall limit is not equal to a number, there is no horizontal asymptote. Let's look at a second example. So we'll do the same thing as we did previously, but now we'll take the limit as x approaches minus infinity of 2x5 minus 3x cubed plus 2x plus 1. So again, in this case as well, we consider only the term that contains the highest power of x. So we are going to consider the 2x to the power 5. So this is the limit as x approaches minus infinity of 2x to the power 5. So that is just 2 multiplied by minus infinity to the power 5. So remember this part over here, we need to be careful whether the power is an even or an odd power. So in this case over here, we know that 5 is an odd number. So multiplying a negative number by itself an odd number of times. So for example, you have minus infinity times minus infinity times minus infinity times minus infinity times minus infinity. So this is going to give you positive, this is going to give you positive, and this is going to remain negative. So the overall sign is going to be a negative. Okay, so multiplying a negative number an odd number of times gives you a negative number. If you multiply a negative number in even number of times, you're going to get a positive number. So in this case, you're going to have 2 multiplied by minus infinity, which is the same thing as minus infinity. So hence, in this case as well, there is no horizontal asymptote, and this limit evaluates to negative infinity. Okay, so now let's look at limits at infinity for rational functions. So in very simple terms, a rational function is simply a function that has a polynomial divided by another polynomial. So for example, if we're told to find the limit as x approaches infinity of x plus 1 divided by 3x minus 1. So straight away we know that this is a rational function because there's a polynomial in the numerator divided by another polynomial in the denominator. So what do we do in this case? So all of that is very much explained in these two lines above. So you take the greatest power of x in the denominator and then you multiply the numerator and the denominator by the reciprocal of this greatest power. So in this case, what is the greatest power of x in the denominator? So in the denominator, the greatest power of x is just this x, right? X by itself. So what do we do next? You multiply both the numerator and the denominator by the reciprocal of this greatest power. So by 1 divided by this greatest power. So I'm taking the numerator and I'm multiplying it by 1 over x, and I'll do the same for the denominator. So it's just multiplying the function by 1 over x divided by 1 over x, and if you think of it, mathematically we're not doing anything because the 1 over x and 1 over x can just cancel out. Now that pretty much does everything for us, so we just need to simplify this a little bit further. So this becomes the limit as x approaches infinity. So x times 1 over x is just x over x plus 1 divided by x divided by 3x over x minus 1 over x. So now this x and x will cancel out. The x over here will cancel out with this x. So that then gives us the limit as x approaches infinity to be 1 plus 1 over x divided by 3 minus 1 over x. So we cannot simplify this any further. So we can at this point try to plug in. If we initially try to plug in, we would have gotten an indeterminate answer. So 1 divided by infinity just goes to 0. And again, the same thing in the denominator, 1 over infinity will give us 0. So overall, this limit evaluates to 1 over 3. So therefore, we can say that the limit as x approaches infinity of our function is equal to 1 over 3. And let's not forget that we are approaching infinity in this case, be it positive or negative infinity, and our answer is a real number, so it's equal to 1 over 3. So in this case, it's fair to say that y equals to 1 over 3 is a horizontal asymptote at positive infinity. So pretty simple. Just look at the highest power of x in the denominator and multiply numerator and denominator by the reciprocal of that highest power. Okay, so let's look at the second example. So here we have the limit as x approaches infinity of 4x cubed plus 5x divided by 1 minus 2x cubed. So right away we know this is a rational function because we have a polynomial divided by another polynomial. So what do we need to do? We need to find the greatest power of x in the denominator. So we know that we have just an x here, and here we have x cubed. So obviously the greatest power of x in the denominator is the x cubed. So again, keep in mind that we are only looking for the greatest power of x by itself. We do not need to consider the coefficient of x at this point. So although the coefficient of the x cube is negative 2, we do not need to do that when we are multiplying both the numerator and the denominator by the reciprocal of the greatest power of x, right? So we'll just multiply both the top and bottom by 1 over x cubed. We do not need the coefficient of the x again. So multiply the numerator by 1 over x cubed, and the same thing for the denominator. So again, the 1 over x cubed multiplies to the whole numerator and denominator. So I mean, that's pretty much all that we need to do, and what remains is to try and simplify this further. So we have 4x cubed divided by x cubed plus 5x over x cubed, whole thing divided by 1 over x cubed minus 2x over x cubed minus 2x cubed divided by x cubed. So let's try and simplify this now. So the x cubed cancels out with x cubed. The x will cancel out with the x cubed to give x square. The x over here will cancel out with the x cube again to give x square, and this x cube will cancel out with the x cube. So that then gives us the limit as x approaches infinity to be 4 plus 5 over x square divided by 1 over x cube minus 2 over x square minus 2. So now if we try to plug in, 5 over infinity square is just going to be 0, 1 over infinity cube is going to be 0, 2 divided by infinity square is going to be 0. So that just gives us 4 divided by minus 2, which is equal to negative 2. So therefore, we can say that the limit as x approaches infinity of our function is equal to negative 2. And since we are approaching infinity, whether it's positive or negative infinity, and our limit is equal to a real number, we can say that y equals to minus 2 is a horizontal asymptote at positive infinity in this case. Positive infinity because we are approaching positive infinity. Okay, so now let's do one final example for this video. So this is the limit as x approaches minus infinity now of 3x squared plus 1 divided by 5x squared plus 23x minus 10. So again, this is a rational function. So what is the greatest power of x in the denominator? So we know that we have an x squared over here, and this is the greatest power of x. So I'm going to multiply the numerator and denominator by the reciprocal of this greatest power. So numerator times 1 over x squared and denominator times 1 over x squared. So now we just need to simplify this, and that should hopefully solve it for us. So 3x squared times x squared is just 3 plus 1 over x squared divided by 5x squared times 1 over x squared is just 5 plus 23x times 1 over x squared is just 23 divided by x minus 10 over x squared. So now at this point it's fair to try to plug in. So 1 divided by minus infinity square is just going to go to 0. 23 divided by negative infinity again is going to go to 0. 10 divided by negative infinity square is also going to go to 0. So again, when you divide by negative infinity, it might seem a little confusing. So just think of it as 1 divided by, for example, 1 million. So your resulting answer is going to be like a negative 0.0000 something. Although it's negative, it's very close to 0, right? So we can just say that it tends to approach 0. So that's an easy way to think of it. So yes, then that leaves us with 3 divided by 5. And guess what? That's it. So therefore, we can say that the limit as x approaches minus infinity of our function is equal to 3 over 5. And since we're approaching minus infinity and our answer is a real number, we can say that y equals to 3 over 5 is a horizontal asymptote at minus infinity in this case, because we're approaching minus infinity. So yes, that more or less sums up the whole idea of finding limits at infinity. So just be careful of what type of function is given to you, whether it's a polynomial, whether it's a rational function, or as we will see in the next video, if it's a radical. Once you know what to do with what type of function you have, then it's pretty simple. Just need to be good with your algebra. Thank you very much for watching.